All right, so in this part of the challenge, you are going to go ahead and create a function that models your the two ingredients you chose in the previous section. So for my example, I chose brown sugar and salt, right? For every 3 cups of brown sugar, I got 1.5 teaspoons of salt. So we're going to create a function that models that because we have a table, which is awesome. Like it tells us how many teaspoons of salt we need for 5 cups of sugar or 20 cups of sugar. But what if I want something that's not in my data table? What if I want to know how much salt for 100 cups of sugar, right? So we want to be able to say what our output is depending on any input we decide. So we're going to create a function to model that. So go ahead and go to page 7 of your notebook. Okay, so write down 7, and then the title should be creating a function. So I'll go ahead and pause the video here if you need to take a moment to write that down on page 7 of your notebook. And then when you're ready, keep playing the video. So we want to be able to write a function that shows the relationship between our inputs and our outputs. So first of all, a function is a relationship between a set of inputs and a set of outputs where there is only one output for each input. So for example, if I put 3 cups of brown sugar, I know I need 1.5 teaspoons of salt. Not 2 teaspoons of salt, not 1. I know it is specifically 1.5 teaspoons of salt for 3 cups of sugar. So for every input, there is only one output. Okay, that's what makes a function. So in this case, we have a linear function, right? We notice there's a linear relationship between our inputs and our outputs. And we want to describe the relationship between our inputs and our outputs. So we notice, we've already mentioned it several times, that whenever, for my example, so for the recipe function, so ingredient function, okay, I know that for every 3 cups of brown sugar, I need 1.5 teaspoons of salt. Okay, so this is like a verbal representation or a written verbal representation of the situation. Now, we don't want to write out such a long explanation every time. So fortunately, with math, we can create equations that tell us exactly what's going on very quickly. So we can say that the output of, essentially my output of salt is always equal to 1/2 of my input of sugar. I'm going to just take this salt away. So my output, whatever my output is, it's always half of my input, right? So this is a way for us to express what's going on. Now we know from our graphs and from our discussions that our output is represented by the y-axis. So we can write our output as the variable y, and our input is represented by the x variable, okay, the x-axis. So we can just write this, instead of 1/2 times the input, we write 1/2 times x. Actually, let me write this in a more clear manner. 1/2 times x, okay? So essentially, we've taken this long written explanation that for every 3 cups of brown sugar, I need 1.5 teaspoons of salt, and said, well, really, I'm taking my cups and I'm making it 1/2 teaspoons of salt. Well, 1/2 of that is the teaspoons of salt. So I can just quickly say, well, y, that's my output, is equal to 1/2 of my input, x. So this is a linear function that represents my situation, okay? So for your ingredients that you chose on page 4, create a linear function that represents what's going on. So my advice is write down what's happening first, figure out where your output and your input is and what's going on with your input to result in your output, and then you can write this linear equation in terms of x and y. So go ahead, work on this, and take a photo of your function and upload it on Dreamseed too.